Okay. And so tell me if we should skip a question. I'll just start. Okay. I think that one's okay.
Yeah, that looks fine. Yeah. That's quite easy. Shall I just try this question? Just
Yeah.
to see. So, 40 kilometers in 2 hours 15 minutes.
Mm-hmm.
So 2.25 hours basically.
Yes.
So they what's the unit they wanted it in?
Nearest whole number. And kilometers per hour.
Right. Okay. So we can say that's 2.25 of an hour.
Yep.
And 40 kilometers. So we divide 40 by 2.25.
Yeah.
Giving us 18 to the nearest whole numbers kilometers per hour.
Okay. Yeah, no problem. Okay. How would you do this?
So you just do 1.024 times what the number is there, 28,500.
Yep. I'm sure you'll be fine for it.
Yeah.
How about this one?
So we have a salary increase of 3%. The increase, so 0.03 equals 702. 1 would equal 702 divided by 0.03 times 100.
And what do you get for this one?
702, 0.03. That gives us 2,340,000.
40,000. So, yeah, you just divide both sides by 0.03. 702 divided by 0.03.
Yeah.
That's fine. Okay.
And do you times that value by 100?
For 100%, yes. Excuse me.
Oh, that's fine.
Or do you? 3%. Let's check. So 3% equals 702. 1% would be divided by 3%, then times 100. Yep. Okay. Describe the single transformation that maps A onto B.
Okay, so A to B, you could say reflection in the line, reflection in, I think that's x equals 6.
Yeah. Rotate the shape, so just use your thing for that. Okay, how do we do this?
Lands on red, so that's x over 3x plus 2x plus 3x. A 1 in 8 chance.
Yep. And then how would you do this one?
So he spins it 200 times, so what's the probability of that? 3x, okay, so 3 over 8 times 200.
Yeah, fine. Okay. So, what will be the first step for this one?
Oh, you just expand the bracket and then rearrange it, yeah.
Yeah, fine.
That's fine.
So, fine. So we did lots of these. How would we do this one?
HJ to 3SF. So you basically use a squared plus b squared equals c squared. We need to find. We've got a and c, so we can say that b equals the root of c squared minus a squared.
Yeah.
And sub in what you got.
Yeah. Okay. How about this? How does this work?
8x minus 3 less than x plus 4 less than 9. So you minus 4 for both sides to get x on its own. So minus 7 is less than x, which is less than 5. Yeah.
5k. So that one, I think you're okay. I think we did it. Standard form, ordinary form, maybe C.
I see. Okay. So this is 9c. Jupiter's a massive. Okay. Work out the value of k. Just 2SF. So J equals Km. What is that? And then I just use the values. So 1.898 times 10 to the 27 equals K, and I'll put in a bracket 3.285 times 10 to the 23. And you just divide to get K. So K equals, I'll type that, 1.8. 27 over we get 5,777. All right, so they want to 2SF, so yes. So 5,800 to SF, yeah.
Fine. It's all right. Okay, how would you do B?
Modal class. So basically the middle value, you add up, or the most common one actually. So we've got, so that's 164W168.
And how about B?
Well, estimate for the total weight of the 60 apples.
Yeah.
Total is 60. And then do you use the range and divide it by the could you say that 162 divided by 12 to get, and then you can add up the totals for the others? And
so that's a good estimate for this, 162.
yeah.
Why is it divided by 12?
Actually, no, I think, yeah, so you have, I'll copy the table. So you times it by 12 because that's how many there are.
Yeah.
And you can actually do the same thing for everything else and then kind of work out an average.
Not an average, total weight.
Oh, they want oh, right, okay.
So that's the same thing done for each one. So how would you go about it?
Uh, 2 seconds, so I'll add them up. You get 10,176.
I got 10,120, I think. Let me just check my input. So data 162, 166, 170, 174, 178, 182. And then the other ones were 12, 20, 14, 7, 4, 3. So I think it's supposed to be I think it's supposed to be 10,120. But
Okay.
I think you have the method.
Yeah.
Okay, so I'm just doing that fancy way. Okay, cumulative frequency, I think you're okay.
Yeah.
And then when you plot the cumulative frequency graph, so let's say this one, so it's 12 and 32. So how would you use that to plot the cumulative frequency graph?
12 and 30. What do you mean by that?
So the first two are 12 and 32. So it'll be the first 2 points on the cumulative frequency graph.
Oh, 32. Oh, you just what?
So what would be
right, sorry. 162 12 and then 164 32.
For cumulative frequency, you use the end point.
Okay.
So so let's say this one.
I'll make a note of that.
Okay.
So the first one will be 164 12, 168 32.
Yes, 168 32. So there are other things where you use the midpoint, like it might be a frequency polygon, something like that. And the reason being is because if there's 12 apples between here, you would, on average, half will be 162 or less, half will be 162 or more, but all 12 will be 164 or less. All 32 are 168 or less, and so those are the ones. I suppose the graph will probably go through the point to 1626. It'll probably go through the point to 164 16, and that'll just naturally happen, but it won't go through 164 32. Yeah. Okay. Cumulative frequency. How would you find the interquartile range from a cumulative frequency graph?
You've got the third quarter of 60. I'll get that. It's 45, so you go 45 y-axis, and where it meets a line, you go down. And then you want to find the first quartile, so that's 15, and you do the same thing.
That's it. Is this one worth doing?
I don't think so. I think it should be fine.
Yeah, and maybe it's just worth mentioning. You have the 991EX, don't you?
Yeah.
So that can get the answers for simultaneous equations. Do you know how to do that?
No, I don't.
So I believe it's mode equation. Oh, sorry, menu equation. I think it's A.
Equation. Yep, A.
Simultaneous equation, and there's 2 unknowns, x and y.
So 2 unknown, yeah.
So do you want to try putting that one in?
Yeah, sure. So 7. Alright, so 7 minus 4 minus 2, okay, equals 41. And then 4x plus 3. It's 11. Yep. X equals 5 and y equals minus 3. Yep.
There you go. X equals 5, y equals minus 3. And that's a good way to check your answer.
Okay.
So there's a reason why they wrote this. Show clear algebraic working. You can't just, get full marks. So that's a 4 marker. Okay. Okay, this looks more like it. Work out the value of x. This is a 4 marker.
Work out x. The pentagon regular. Or does it not mention?
Let's take a look. Regular. Yeah.
Oh, no. I'll draw that.
Let me just. There we go.
So then if it's a regular pentagon, we can use so n minus 2 times 180 gives us, so 3 times 180. Yeah. 540.
Okay.
So 540 divided by 5 gives us 108. So that angle y is 108.
Mm-hmm.
And then we know that both y's are 108. And we have 1, 2, 3, 4. So 4x plus 216 equals 360. No, wait, I'll do so those x values are equal, so this is a regular hexagon.
Does no, because it's got x and y.
Okay. So
Sorry, go on.
trying to work this one out. So we've got
okay.
You know the n minus 2 rule. Does that work for any? Like, could it be an irregular hex, like a pentagon or whatever?
What does the n minus 2 rule tell you? What the angles add up to?
Yeah, the interior one.
Yeah. That'll
Okay.
work for irregular as well.
So if you just draw a straight line, kind of from like between QP and then between LM, so just to join those two.
And L. Okay.
So say that 2x plus 108 plus 90 is 720. Or no, it's 540. Sorry, 540. Because seconds.
Okay, so what do you get?
So 2x is 540 minus 198. 342. So x must be half of that. So 171 degrees.
I'm not sure. Angles in a triangle add up to
180.
quadrilateral.
360.
5 sides.
540.
And so 6 sides.
That's 1080.
What's going up in each time?
It's doubling. Yeah.
No.
The sides are going up, but
Plus.
all right. You add 180.
Yeah.
So that would be 720.
So that's 720. So 6 sides is 720. So that's just my way of doing the n-2 rule. I can never remember that rule. So it's 720. Where's my calculator gone? And you want. So it's 720, which is the total of the 6-sided one. Minus 108. Minus 108. And then we're left with those 1, 2, 3, 4 x's. So divide that by 4. I got 126. What was your answer?
I got 171, but I might be wrong.
Am I right in saying that you put 190 instead of 290s?
That's why. Yeah.
Yeah. So okay. So yeah, there's many ways to do it. If you're not sure, it's not a bad way to do it. But yeah, just watch for little things like that. And if you're stuck, you can just keep adding 180 to the number of sides, and that'll work. Any questions there?
No, that's fine.
Okay, so that was a pretty tricky one. So it's a 4 marker. How do we do this?
Where? 0. So they want us to use the quadratic formula. So I'll write what A, B, and C are.
Yeah.
A is 4, B is 6, C is minus 1. So minus B plus or minus the root of B squared minus 4AC over 2A.
Next step.
So just sub in what you've got. So minus 6. I'll start with plus or minus.
Let's, for the working out, just put it as plus or minus.
Okay, yeah.
So minus 6 plus or minus.
Plus or minus root of, so 6 squared minus 4 times 4 times minus 1. All over 2 times 4.
What would you do next?
You just sub that. You can type it in the calculator. So
I personally would do equation.
Okay.
So polynomial degree of 2 because it's x squared.
Okay. Wait. So polynomial degree of 2. Yeah.
Because it's x squared, and just put in a, b, and c.
Oh, nice. Okay.
Because they, that's a valid way of using your calculator, and they don't know that you didn't do the longer way.
Okay. That's great. So we get 0.151
Okay.
for x1, and x2 is. Okay, we have x2 is minus 1.65.
Yeah, minus 1.65. There we go. They have no idea that you didn't do it this longer way, and if you did it this longer way, you would have gotten the exact same numbers.
Yeah.
So this part is the method mark. So that's clearly like the method. Like, so you have the formula, subbing the numbers into the formula, and that's an accuracy mark. That's an accuracy mark, and I don't know how many marks it is in total. So 3 marks. So that's what the 3 marks are for. Yeah, you don't get any mark for doing 6 squared. You know, just get the marks. Okay, how about this one?
We want the sides of GFE. I'll draw that as well. So they want the actual angle of GFE. Is that what it was?
Yeah.
Okay, so we can tell the angle of D, and that would be half of 98, which is 45 plus 4, 49. And then the angle of F, because this is a cyclic quadrilateral, they'll add up to 180 each side.
Okay.
So we have 180 minus 49. That's 131 degrees.
Okay. I'll give a reason for each stage of your working.
Okay, so for the first stage, the angle at the circumference is twice that at the center.
That was the angle GDE, was it?
GDE, yeah.
And does that angle look twice as big as the 98?
So the angle at the circumference is like half the size, yeah.
Yeah. Or it can be written the other way around. The angle at the center is twice the angle at the circumference.
Yeah.
Okay, so that's how we got GDE. And then there.
Opposite angles in a cyclic quadrilateral out to 180.
Yeah. It's probably a 4 marker. Yep. So 1 mark for the first number, 1 mark for the final answer, 1 mark each for the 2 reasons.
Okay.
Is this one worth doing?
I might try that just to make sure I can.
Okay.
2 over x minus 1 over x plus 3. We can write that as 2 and then in a bracket x plus 3 over x and then x plus 3 minus 1 and then x, like in a bracket, over x and x plus 3 again. Two x plus 6 over x squared plus 3x minus x over x squared plus 3x equals x plus 6 over x squared plus 3x.
I'm just going to leave that in the bracket. And so what was on top?
X plus 6.
Okay. The reason why I left that in a bracket is because it might have simplified. Like if that was x plus 3 on the top, the 2 would cancel. Yeah, just make sure. X plus 3, x plus 3. X and x. 2x plus 6 minus x. So it didn't simplify. Okay. So this one will.
Just before, is this the paper that's in the mock at all?
Which mock?
The GCSE mocks. Do you know if this is the?
So this was the paper from 2018. 2018 in June.
Okay. Okay, that's okay.
So I don't know if that's the one you did in your mock or whatever.
No, because I've got my mock coming up, so that's
Okay. Well.
Yeah.
So most people won't have access to this paper, so maybe they'll use it. But I don't know what they'll use.
Okay.
But it's as similar as, you know.
It's fine. Okay. 9x squared minus 4 over 3x minus 17x plus 10. So we can just what was there was a factorizing. Was there a way to factorize with this calculator?
There's a way to kind of, so no, in theory. In practice, what you can do is do that same thing, but put in a is 3, b is minus 17, c is 10.
Okay. Okay, we get x to be 5 and 2/3. Yeah.
So x equals 5 when it's equal to 0, or x equals 2 over 3. And so you just figure out what would have been in the bracket.
Yeah.
To get those answers.
Okay, so we have obviously 3x and x as our things. So I think it's 3x. What was it? Plus.
So if this one here was 3x.
That would be. Yeah, so 3x equals 2, right? So then. So you have minus 2 in the bracket for 3x.
Yeah.
And then you have minus 5 in the bracket for x.
Yeah.
And we know that on the top, the same. So we've got 9x squared. And minus 4. So we've got x equals, again, 2/3 or minus 2/3.
Okay.
So we have, we can only really have 3x and x here. So, no, 3x and 3x. 3x plus 2, 3x minus 2.
Uh-huh.
And we've got 2 3x minus 2's on the numerator and denominator. So we can have 3x plus 2 over x minus 5.
Yeah. So it might be a bit quicker way to do it.
Yeah.
Any questions there?
No, that's fine.
Okay. Okay, area of this triangle.
Okay, so the area is, it's half AB sine C. Yeah.
Yeah.
Cool. C giving us a half times 12.7 times 18.5 times sine 78.
No. What if that's A and that's B? What is the angle C?
Well, C would be PRQ.
So that would be the angle A.
So that would be, yeah, between A and B. So it would be angle Q, PQR.
Yeah. So you have to get the angle between. So it's always two sides and the angle between them for area.
Okay, so I think we'd need to use. Oh, no, it's not right angle. So. So A over sine A equals B over sine B. So we can then find C that way.
Uh-huh.
Somewhere else, isn't it? Or B. Yeah. A over sine. Sine A over A actually would be easier.
Okay.
And we get the thing on its own. So sine A over what do we have? Yeah, sine A over 12.7 equals sine 78 over 18.5. Sine A equals 12.7 times sine 78
Mm-hmm.
over 18.5. A is inverse sine of the answer. Plug that in. So, right. Shift sine, and then uh, 42.182
Okay.
for angle A. So we can say that angle C is so C is answer plus 78. 80 minus that. Yeah. Minus answer plus. Right. $59 point. How many significant figures they want?
Let's do it to 5 sig fig for the moment.
Okay. So 5.818.
Yeah.
Breathe. Yeah. So now we want the area of this whole thing. So we do a half times 12.7 times 18.5 times sine 59.818.
And the final answer to 3 sig fig.
Okay, so 102 cm squared.
That's it. And did you use answer or 59.818?
I used 59.818.
And because we did it to 5 sig fig, it rounded correctly.
Okay.
And you can see it was right on the line there. So maybe 59.8 wouldn't have been correct. Let's try 59.8. Yeah, still would have just rounded the right way. Okay. So 102 centimeters squared.
Yes.
Okay, any questions there?
No, just with with the questions on geometry and area. What would the key things to kind of bear in mind, or
So for this one, it's a half times any side times any other side times sine angle between the two sides you picked.
Yeah.
And so you go from there. The cosine rule. The cosine rule. So any triangle it can be used for. Used for scaling really, because if it's a right angle triangle, there's easier ways. It's when you have 3 sides or 2 sides and the angle between, so similar to the area. Anything else?
No, that's fine. Yeah.
Sine rule. Yeah. So cosine rule is for any triangle. It's when you have 3 sides or 2 sides and the angle between the 2 sides. Any other circumstance, use the sine rule, and that's for scaling triangles, and it'll work for any triangle. Okay. But SOHCAHTOA is works for right angle triangles only. Okay. How would you do this one?
6 plus root 10 over root 2 equals, we times both sides by root 2, so 6 root 2 plus root of 20 over 2.
And is that it done?
No, not yet. So we have to get root 20 as, so 6 root 2 plus 4 times 5, so 2 root 5 over 2, giving us 3 root 2 plus root 5.
And if you're stuck, let me change this back. Shift, no. If you're stuck, originally it was 6 root 2 plus root 20 over root 2. Oh, sorry, over 2.
I think it was 6 plus root 10 over root 2.
So I multiplied the top and bottom by root 2.
Oh, fine, yeah.
But you're correct. You can literally just put in the question. 6 plus root 10 over root 2. And that will guide you towards what you need to do. Root 5 plus 3 root 2.
Yep.
And they wanted it as 3 root 2 plus root 5.
Okay.
So same thing. So the calculator automatically rationalizes it. Excuse me. Oh. So this one might be worth doing.
Okay. I'll draw the straight line. So moves along this line. So displacement of the particle from the fixed point. Oh, yeah. Times t is greater than 1 or equal to 1. It is equals 1 in s meters, where s is 3 plus 1 over t. Find an expression for v in terms of t. At time t, the velocity is v meters per second. So we basically have the number of meters here, and we need the meters per second. So 3 plus 1 over t divided by t, I think. equals V. That. Okay, so S over T equals V, which equals 3 T over T. So yeah, V equals 3 plus 1 over T over T. So we can say that Vt equals 3 plus 1 over T. What do we want in terms of T? So we want the T basically on its own. So 1 over T equals Vt minus 3.
Yeah.
Okay. 1 equals Vt squared minus 3t. Oh no.
So I think it'll work.
Okay, so Vt squared minus 3t minus 1 equals 0. And we know that the V... Okay, so we can then use the...
Any idea?
You try and factorize this.
No. That would be if you're making T the subject. You want to make V the subject.
Oh, right. Okay. So, yeah, that's all right then. So, V equals 1 over T squared minus 3T.
Yeah.
That's all right.
Okay. Excuse me. Find the acceleration of the particle at time 6 seconds.
At 6 seconds. So we have our... wait. Do they want the velocity at 6 seconds or what?
Acceleration.
Okay. That's meters per second squared.
Yeah.
So we've got our formula for the speed, but we need to divide that again by the time. So V equals 1 over T squared minus 3T. And we can use A for acceleration equals 1 over T squared minus 3T over T again, which is 1 over 6 squared minus 3 times 6 divided by 6, which is 1 6 squared minus 3 times 6 divided by 6 again. They want it in...
They didn't say seconds. Time 6 seconds, so it will be meters per second squared.
This looks really slow, but 9.26 times 10 to the minus 3 meters per second.
So
Well-
yeah. I was dubious about it. Let's see. Straight line. Oh, lies on line. Is S meters? Let's see. The particle is this. I just want to see. So this is question 18. See what's given to you. Okay, so they don't give you those ones. So question 18, that's 21. So 1 over is yours 925? Does yours involve 925?
925, yeah.
Yeah, you're correct.
Oh, I'm correct. Cool.
That's the answer, yeah. Yeah, how was that for you, Stefan? So we did most of the questions. There's 21 questions. We did 1 to 18.
Well, that's great, because it's a 2-hour paper, so that's good.
So if you like, we can continue like this. And maybe we can work backwards or something.
Yeah, could you email me perhaps like a paper for me to do in the time until the next lesson?
Okay, yeah. Any questions for me in general?
Do you know if there's like a guide or something to use the the FX 91?
Yeah, just Google 991EX user manual.
Okay.
Yeah, I'll try to email as well. Anything else?
No, that's fine. So.
Okay. Well then, Stefan, you're doing great. I look forward to trying again next time.
See you next time. Bye-bye.
Goodbye.